Now we're going to learn how to approximate to the nearest 10,000, 100,000, and million. And with this knowledge, actually, you can approximate to 10 million, 100 million, 1 billion, 10 billion, and as much as you want to go. Just like we always do, we need to round off the first digit after the specified digit. That is to say, if we want to approximate 2,153,627 to the nearest million, we need to locate the million digit. The million digit here is 2, so we got to round off 1. If we round off 1, we'll be doing just the right thing. And right down here you see 1 being rounded off, and then you got from 1 and all the digits to its right become zeros, so you have 2 million to the nearest million. Same goes for this. This is 3,217,182 to the nearest 10,000. The 10,000 digit here is 1, this very one. So we need to round up 7. Rounding up 7 will make this become 2, and so you have 322,000, and that's what we got here, 322,000. And then if we need to round off 8,132,114 to the nearest 100,000, we need to locate the 100,000 digits. The 100,000 digit is 1. So we need to round down 3. And so this becomes 81,000,000. And that's what you got here, 81,000,000. Now in the further explanation page, if you click on this, we get to see just about the same thing. That if we want to approximate to the nearest million, then the 100,000 digits should be rounded off, because it's just the digits to the right after the million digits. And if we want to approximate any number to the nearest 10,000, we need to round off the 1,000 digits. And if we want to approximate any number to the nearest 100,000, we need to round off the 10,000 digits. So it goes like that every time you're told to approximate to the nearest anything. Just locate the digits of that thing and then round off the first digit after it to the right, and you'll be good. Approximate 2,731,932 to the nearest 1,000. I think the 10,000 digit here is 3, so we are going to clear 1932, and we're rounding down, so it remains 273. So that's it. Approximate 4,229,153 to the nearest 100,000. I think that the 100,000 digit here is 2, this first 2. So we are going to round down this other 2, which is the 10,000 digit, and so we get 0,0,0,0,0, and this remains 42 still. If we are going to approximate 7,821,945 to the nearest million, the million digit is 7, so we're going to round up 8, and 8 down to 5 will all become zeros. and because 8 is being rounded up, it gives 1 to the 7, making it 8. And to approximate 27319,405 to the nearest 10,000, we need to round off the 1,000 digit. The 10,000 digit is 1, so the 1,000 digit is 9, and that will mean rounding up 9. If we round up 9, we got 2732,0000, and that's this. To approximate 5391967 to the nearest 10,000, we need to locate the 1,000 digit, which is 1. So we're going to round off 1, because 9 is the 10,000 digit, so 1 is the 1,000 digit. So if we round up 1, we get 0000, and then this remains 500. Want to teach you how to approximate decimal numbers, but we're beginning from here, where I will be showing you how to round off digits in a decimal number, like this number 439.35. If you're going to round off 9, which is a rounding up situation, you do just what you used to do. Make 9 and the digits to its right become zeros, and add 1 to 43 left behind. You'll get 440.00. So you'll notice that 43 becomes 44 as usual, and that 9 is 0, and the point remain in its position, and then 35 is 00. If you do the same thing to 32412.5 and you round off 4, you'll get to round down 4, so you have 32412.5 becoming 32000.0. Just notice that the point should remain where it is, even when all the other digits become 0. And then you also notice that the point determines where the number stops. So every zeros that come after the decimal point are actually knocked off. Anyway, there is a rule against that, and when we get there, we'll let you know. To round off 6 into 1.362, that is 21.362, you just knock off 6 and 2, being the required digit and the digits after it. Then you get 21.400. So here again, the zeros are knocked off. Just a lesson, you know. On the further explanation page, you would see something quite interesting, and it's just to buttress the same point, and that is to say, abide by the rules of rounding down and up, and place the decimal point where it was before rounding off. The zeros after the decimal point may be removed depending on what kind of approximation you're doing, as shown later. So we got that right. Round off 3 in 4123.72. 3 should be rounded down, so we got 4120.00. So the 0.00 goes So we have 4120, and that's it. Round off 5 in 8.539. 5 will be rounded up to make 8 become 9. 539 becomes 000, which are all after the decimal point, therefore they will be wiped out. So you got 9 to be your answer. Round off 1 in 214.32. 1 should be rounded down, and so we get 200.00. 00 after the point is gone, so we have 200 left, and that is this. Round off 0 in 310.29. 0 should be rounded down, so we have 0.00, and 31 remains the same, so we have 310.00. 00 after the point is knocked off, so we have this. If we continue that, we have round off 4 in 62.3451. 62.3 is left untouched. 4 and all the digits to its right becomes 000. So we have 62.3000, which leaves this the answer. Here I want to show you how to round off decimal numbers to the nearest 10, 100, and 1000. Actually, with this knowledge, you can do beyond 1000. You can do up to 10,000, 100,000, million, and as much as you can go. So now we begin here to approximate 3241.72 to the nearest 10. As usual, locate the 10 digit, which is 4, and then you round off the digit just immediately after it to the right, and every other digit along that side. So if you're going to round down 1, you're going to have something like this. You now have 3240.00, and the 00s are knocked out, so you have 3240. Same way, if you want to approximate 4193.5 to the nearest 100, the 100 digit is 1, so you're going to round off 9, and that will be a rounding up situation. So 9 becomes 0 and all the digits to its right, which means you now have 4200.0, and the 0 is knocked out, so you have 4200. And the same way, you want to approximate 3284.63 to the nearest 1000. The 1000 digits here is 3, so you're going to round down 2, and if you round down 2, you would have 3000.00, and then that is 3000 because the 00s are knocked off, and you got that to the nearest 1000. So I want you to see that it's quite simple. It's just like what we did in the previous stage. So let's see what is there in the further explanation page. In the further explanation page, we have that by place values, notice that the 10 digit is 4 in 3241.72. Therefore, the number to be rounded off is 1, because it is the first digit after 4 to the right. So we keep up the same rules we've always used. The first question is approximate 631.24 to the nearest 10. If it's to the nearest 10, then the 10 digit is 3. So we're going to round down 1, and that would become 0.00. So we have 630.00, and that will just be 630 when we are done. And number 2 is approximate 8219.6 to the nearest 10. The 10 digit is 1, and so we're going to round up 9, and that will give 1 to this one to make it 822. So you have 8220.0, and that should end up as 8220. 3. Approximate 3273.14 to the nearest 100. If we do that, the 100 digit is 2, so we need to round up 7. And 7 we give 1 to 2, making it 33. So we have 3300.00, and that would be 3300, and that's just this. And if we continue that way, we need to approximate 273.62 to the nearest 100. Then 100 digit here is 2, so we need to round up 7. 7 we give 1 to 2 to become 3, so we have 300.00, and that becomes 300. And finally, number 5, we have this question: approximate 4196.8 to the nearest 1000. Of course, the 1000 digit is 4, and we are going to round down 1, and 1 becomes 000.0. So we have 4000.0, which is 4000. Here I want to show you how to approximate to the nearest 10th. You know, the 10th digit is actually the first digit after the decimal point to the right. So like we always do, if you want to approximate a number to the nearest 10th, simply round off the digit immediately after the 10th digit to the right. That is in 217.482. Seeing that the 10th digit is 4, you need to round off 8, and that would just be fine. So 8 would be rounded up to make this become 5, and you have 00, so you have 217.500, which is now 217.5. If you need to approximate 521.93 to the nearest 10th, the 10th digit is 9, so you're going to round off 3, which is rounding down. So 3 becomes 0, so you have 521.90, which is equal to 521.9. And lastly, if you need to approximate 6.4817 to the nearest 10th, round off 8, because 8 is the digit after the required digit, which is the 10th digit 4. So you have 8 being rounded up to become 6.5000, and that's what we got here, 6.5000, which in turn is 6.5. So if we hit the further explanation button, we get to see what is in there, and it's just saying that the 10th digit is the first digit after the decimal point to the right, and all I said before. So the reason why we have to round up 8 is because 8 is the digit after the 10th digit, which is 4 to the right. And if you go on like that, you see why everything was done the way they were done. The first question is approximate 619.47 to the nearest tenth. Of course, the 10th digit is 4, so we're going to round up 7 to make this 4 5. So we have 619.5. Approximate 83.562 to the nearest tenth. Of course, the 10th digit is 5, so we're going to round up 6 to make this 5 6. So we have 83.6, and that's this. Approximate 119.63 to the nearest tenth. The 10th digit is 6, so we're going to round down 3. And 3 will be rounded down to be 0, so we have 119.6. That's it. And next question is approximate 201.073 to the nearest tenth. The 10th digit is 0, so we're going to round up 7 to make this 0 become 1. So we have 201.100, which is 201.1. And the next question is approximate 239.58 to the nearest tenth. The 10th digit is 5, so we're going to round up 8 to make this 5 become 6. So we now have 239.6, and this is it. Here we want to teach you how to approximate to the nearest 100. You need to know the 100th digit to be able to approximate to the nearest 100. And it's so simple. The 100th digit is simply the second digit after the decimal point to the right. So after every decimal point, you have the 10th digit, then you have the 100th digit. So if I want to approximate 517.482, I should know that 8 is the 100th digit. So I will round down 2, and that becomes 517.480, and which is 517.48, and that's what happened here. The same way you go if you want to approximate 6.3817 to the nearest 100. The 100th digit here is 8, so we are going to round down 1. So we have 00 coming from 17, so we have 6.3800, which would become 6.38. The same way you go if you want to approximate 83.569 to the nearest 100. The 100th digit is 6, so we are going to round up 9, and 9 becomes 0 and leave a 1 added to 6, so we have 83.570. So we got 83.57, and that's it. On the further explanation page, I believe you'll need to learn here what the 100 digit is. Exactly, the 100 digit is the second digit after the decimal point to the right, and every other thing already been explained. The first question I see is approximate 49.3621 to the nearest hundred. Now the hundredth digit is 6, so we are going to round down 2. So we have 00, so we have 49.3600, so we have 49.36 as our answer. If I want to approximate 8.2714 to the nearest hundred, the hundredth digit is 7. So I'm going to round down 1 to get 00. So we have 8.2700, which is 8.27, and that is this. If I want to approximate 0.9382 to the nearest hundred, the hundredth digit is 3. So I'm going to round up 8 to make it 4. So I have 0.9400, and that becomes 0.94. If I need to approximate 0.0673 to the nearest hundred, the hundredth digit is 6, so I need to round up 7 to make this 6 become 7. So we have 0.0700, so we have 0.07 as the answer. And finally, to approximate 8.314 to the nearest hundred, notice that the hundredth digit is 1. So I'm going to round down 4 to become 0. So it becomes 8.310, and that is 8.31. And here is a purple bet, and I want to show you how to approximate to the nearest tenth and hundred when 0 is left in its place. Now, I once said in a stage earlier that there is a rule against knocking off the zeros after the decimal point, and here we are faced with one of such rules. Generally, the zeros at the last position after the decimal point are knocked off after approximations, e.g. 36.800 is written as 36.8. However, when approximating to the nearest tenth hundred, the zeros required to fill up the space of the specified approximations are left untouched. That's just it. For example, if I approximate 18.041 to the nearest tenth, I expect that I should have 18.000 because 4 is rounded down. And then I should have knocked off the 3 zeros here, but I won't do that because I was asked to approximate to the nearest tenth. I have to leave a 0 in the 10th place to represent my approximating to the nearest tenth, and that's the rule. So the same way, if I approximate 5.987 to the nearest tenth, I'm going to get 5.9 and 8 being rounded up to this becoming 6.0. So 6.000 is what I'll get, making it 6.0 because I have to leave 1 0 in the 10th place. And then also 27 to the nearest tenth. Quite impressive to know that 27 as a whole number is not alone. 27 as a whole number actually could be expressed as 27.00000000 as much as you can represent. However, if you want to approximate 27 to the nearest tenth, revealing all the other zeros it can contain, you realize that you need to knock all of them off except the one in the 10th place, and so you got 27.0. Now coming to the nearest hundredth, the same thing you're going to do. If you were to approximate 5.0032 to the nearest hundredth, you would have just done 5.00, then 32 is rounded down to be 00, and we would have just said 5, knocking off all the zeros. But no, because it's to the nearest hundredth, we leave the 2 zeros that will represent to the nearest hundredth, and so we got 5.00 as the appropriate answer to this question. 16.695 to the nearest hundredth should become 16.700 because 5 is rounded up, and with 1 on 69 it becomes 70, so we have 16.700. So one of the zeros alone is knocked off, so you have 16.70, so you can maintain 2 digits for the sake of nearest hundredth. Same goes for 14 to the nearest hundredth. Like I explained before, a whole number such as 14 could be represented as 14.000000 as much as you can, right? However, we knock off all the other zeros and we are left with just 2 of them to represent nearest hundredth. So if it is to the nearest thousandth and whatever it is, you just leave as much zeros to represent them. So to the nearest thousandth, you should have left 3 zeros, and so it should have been 14.000, and so on and so forth. So now that is it, and we can check our further explanation page to see what's up there for us. In the further explanation page, we have, as usual, to approximate 18.041 to the nearest tenth, round off 4, the result is 18.000, which should be written as 18.0 because the 10th place must be occupied. Same goes for every other thing that has been done. Let's take one of such example on the nearest hundredth. In the same way, to approximate 5.0032 to the nearest hundredth, round off 3, the result is 5.0000, which should be written as 5.00 because the hundredth place must be occupied. So that is how we go, and now we can go ahead. The first question here is approximate 6.01 to the nearest tenth. We would have 6.00 out of this, which should become 6.0 to the nearest tenth. Approximate 8.95 to the nearest tenth. If we round up 5, we would have 9.00. One of the zeros alone is going to be knocked off, so we still have a 0 left in the 10th place, so we have 9.0. To approximate 4.995 to the nearest hundredth, 5 will be rounded up because the 100th digit is this 9, and that makes this become 5.000. Now we should go off with just the last 0 because we need enough zeros to fill up to the 100th place, and so we got 5.00. And next question is approximate 16 to the nearest hundredth. 16 to the nearest hundredth should just be 16.00. Enough zeros out of the infinite zeros that could be written here. Enough zeros to fill up the 100th digit, please. And lastly, we have approximate 18.197 to the nearest 100th. Of course, 7 should be rounded up. So we have 18.200. However, we need it to be 18.20 so there be enough digits to fill up the 100.